Sometimes you need to work directly with the raw MCP protocol without any client-side processing getting in the way. We'll see how to bypass FastMCP's automatic deserialization and error handling to get the unfiltered CallToolResult object, giving you full control over the response, exactly as the server sent it.
Async with client. Result equals await client. CallToolMCP, potentially failing tool. Param, value. Hash result, MCP, types, CallToolResult. If result is error. Print F tool failed. Result content. LC. Print F tool succeeded. Result content. Hash note. No automatic deserialization with CallToolMCP.
This demonstrates the raw protocol access pattern in RPC systems, where you bypass framework abstractions to work directly with the underlying protocol objects. Unlike the standard CallTool, which provides automatic deserialization and error handling, this approach gives you the unprocessed response from the server. The distinctive aspect is that you trade convenience for complete control over the response handling pipeline. The pattern works by exposing the protocol's native result structure, in this case the MCP protocol's CallToolResult object. This preserves all original metadata, content blocks, and error states exactly as the server produced them, without any client-side interpretation or transformation. You manually inspect the as-error, flag, and raw content blocks, making all parsing decisions explicit in your code rather than relying on framework conventions. This approach matters when you need to handle non-standard server responses, debug protocol-level issues, or implement custom deserialization logic. It's particularly valuable when working with legacy systems, experimental features, or when the framework's automatic handling conflicts with your specific requirements. The trade-off is increased verbosity and responsibility for proper error handling and data extraction. Let's break it down line by line.
Async with client.
This uses Python's async context manager pattern. The async with block ensures the client connection is properly initialized and cleaned up, preventing resource leaks even if the operation fails. Critical for production-grade async code, where manual cleanup would be error-prone.
Result equals await client. CallToolMCP, potentially failing tool. Param, value.
This invokes the tool named potentially failing tool with the provided parameters, using MCP's low-level call interface. The CallToolMCP method returns a raw CallToolResult object that requires manual error checking, unlike higher-level wrappers that auto-deserialize responses. This is the direct RPC pattern when you need full control over the tool execution flow.
Hash result, MCP, types, CallToolResult. If result is error.
The CallToolResult object contains both success and error states in one response. The as-error check handles this union type, letting you branch logic based on execution outcome.
Print F tool failed. Result content.
This outputs the error content when the tool call fails. The result content contains the error message from the MCP server, providing immediate feedback for debugging failed operations.
LC.
This else branch handles the success case when the tool execution completes without errors. It processes the successful result from CallToolMCP, which requires explicit success failure checking since the method doesn't raise exceptions for tool failures. The pattern mirrors standard RPC-style error handling, where status codes drive control flow.
Print F tool succeeded. Result content.
This outputs the successful tool response from result content. The raw content is printed directly since CallToolMCP doesn't auto-deserialize responses, requiring manual handling of the result payload.
Hash note: no automatic deserialization with CallToolMCP.
This comment warns that CallToolMCP returns raw content without automatic JSON deserialization. Unlike higher-level methods, you must manually parse the result content if it contains structured data. Raw MCP protocol access. The CallToolMCP method gives you direct access to the underlying MCP protocol, bypassing FastMCP's automatic deserialization and error handling layers. This method never raises exceptions for tool failures, requiring explicit checks of the iserror flag. You gain complete control over the raw response object at the cost of manual result processing.
The protocol that reveals itself loses its magic, yet gains all power